Hello students, my name is Halim.
And I am Azrina. I want to bring your attention to the video that you have watched at the beginning of the lesson. What can you see in the video? Don't worry, if you can't remember, my colleague Halim will explain to you the scene which you have watched.
Thank you, Azrina. The man who came to the farm just now was Mr. Hadi. He reared sheep and therefore he went to the farm to buy 20 sheep. Therefore, in order to keep all of the sheep, Hadi needs to build a fencing area for them. So our task today is that we are going to help Hadi and his son Amin to build a fencing area for their sheep. In order to complete the task, what do you think the mathematical concept that we are going to discuss today? Well students, throughout this video, you will apply your knowledge in algebra to form a quadratic equation. Then, using quadratic equation, you can help Mr. Hadi and Amin to find the maximum area through several methods such as trial and error method, drawing graph, and differentiation of calculus. Before we go to the next scene, I have a question for you. Why do you think that Mr. Hadi and Amin would like to maximize the area of the pen? We will keep the question until the end of the lesson. Now, let us watch the conversation between Mr. Hadi and his son Amin.
Dad, where are you from?
Actually, Amin, I just bought 20 sheep from Akmal Tani's farm and they are expected to be delivered to us next week. Therefore, before they arrive, we have to build fencing area for them. Since you are my reliable assistant, could you please help me to put up fences towards that existing fence?
Sure, Dad. What should I do now? How can I help?
I will give you a 25-meter wire mesh to fence a rectangular pen for the sheep by using the existing fence as one side. Now, what you need to do is calculate the area that we can cover using the 25-meter wire mesh.
Now, for any given pen design, can you help the son to calculate the area covered by the pen? You will have to work in small groups. Each group will be given a piece of grid paper. Please follow instruction given by your teacher and see you in a while. Now students, did you manage to do the activity successfully? Let's watch the video again to see the son performance. You can use your previous knowledge of algebra to calculate the area.
Dad, I already got the answer.
That's great, son. Can you show me how did you get the answer?
Let me show you.
The formula for area of rectangle is length multiplied by width. If x refers to two equal sides, the equation for the area is y equal negative 2x squared plus 25x. If x represents the longest side of the pen, y equals negative 1 over 2x squared plus 25 over 2x.
That's great, Amin. Now we already know the area in general. But what if we design a rectangular pen so we can get the maximum area?
Wow, this is getting more challenging. Maybe we can use trial and error method.
Can you help Amin to use the trial and error method so they can get the maximum area? You can help Amin to complete this table. Do the activity in groups. Okay students, were you able to do the task? Let us see whether Amin and his father are able to complete the mission. Let's watch the continuation of the video.
This is the table which I have completed, Dad.
Look at Amin's table and compare the answers with yours. Now, let us watch the video again.
Are you sure that 78 meters squared is the maximum area for the pen?
Why not, Dad? Based on the table, 78 meters squared is the largest area that we can get.
What do you think? The table shows that Amin only substitute value x with the whole number. In that case, how we can be sure that 78 meters squared is the largest area? Maybe we can help Amin by drawing the quadratic graph and find the maximum value from the graph. Could you help Amin to draw the graph so that he can prove it to his dad? Do the activity now. Were you able to solve the problem? Let us watch the video again to see whether Amin has a change of mind.
Yes, you are correct, Dad. I was wrong. Here the quadratic curve, that you can see maximum value from the graph clearly.
Well done, Amin. You are doing great. I can see clearly from the graph that the largest area could be a value between 70 meters squared and 80 meters squared. However, I am still not satisfied because I still do not know the exact maximum value of the area.
Oh, you are still not satisfied? Really? Give me a moment to think.
Now students, how can we help to satisfy Amin's father? Is there any method that we can use to help him to find the exact maximum area? Do you know that we can use differentiation method from calculus to solve this problem?
Differentiation method is the process of finding the derivative of a function. The derivative of a function at a point can be defined as the gradient or slope of the tangent line to the graph of the function at this point. One important application of differentiation is in the area of optimization, which means finding the condition for a maximum to occur. Now, take a look at how I find the derivative of the first equation of y. This is the first equation of y. The derivative for negative 1 over 2x squared is negative x. The derivative for 25 over 2x is 25 over 2. Hence, the derivative for the whole equation is negative x plus 25 over 2. However, dy dx is 0 when the value of x is either maximum or minimum. So, how to assure that this derivative gives the maximum value, not a minimum? For that purpose, we have to find the second derivative of this equation. Using the same method as the first derivative, the second derivative for negative x is the second derivative for 25 over 2 is, hence, the derivative for the whole equation is. Based on concavity theorem, if the value of d square y over dx square is negative, then the graph of this equation is concave downward. Thus, disproving that the first derivative gives the maximum value. Therefore, since the first derivative gives the maximum value, dy over dx is equal to 0. Thus, 0 equals negative x plus 25 over 2.
That this is how I solve your problem.
Do you get the same answer? Now, let's compare this answer with the one calculated using the grid paper. Is it the same?
You are really brilliant. I am proud of you, son. Later, we can apply this concept to fence our pen in a wide area.
Sure, Dad. After this, I will figure out whether it is possible to get the maximum area using other shapes such as isosceles triangle, which is a triangle that has two equal sides.
Now, let us help Amin to calculate the suggested area by using 25-meter wire mesh to produce an isosceles triangle whose base against the existing fence is x. Find area as a function of x. How does that compare with your base rectangle? Do the activity in groups. See you in a while. Hi there. Did you manage to do the task? My friend Azrina is here to help you.
Hi, I'm back. I will explain the answers to the question.
Using the Pythagorean theorem with the height of the triangle h, we can write, solving for h, we find the formula for the area of triangle is 1 over 2 times length times width. Therefore, area of the isosceles triangle with respect to x is represented by ax. Then, substitute the x with these values. You will get the values of a. From the trial and error method, we find that when x is 0, the value of a is also 0. And when x is 25, the value of a is 0. Don't you see this familiar? We can see clearly from the graph that the largest area could be when the value of x is between 17 and 18. To find the value of x that gives us maximum area, call it x star, we take the derivative of ax with respect to x, set the resulting equation to 0, and solve for x. By moving this to the left side, the equation becomes, by dividing both sides by 1 over 2, we'll cancelling the 1 over 2 terms. Then the equation becomes, and then multiplying by square root of 12.5 square minus x over 2 square on both sides, the equation becomes, after rearrange the equation, hence, so it is proven that the value of x so that the area of the isosceles triangle is maximized is 17.68 meters. Finally, by substituting x star equals 12.5 square root of 2, the maximum area is.
Does that imply anything about the type of triangle you have derived? Can you prove your hypothesis?
If we have created a right triangle, then the Pythagorean theorem would apply to the three sides. So, let's check to see if this is true. We square each of the equal sides and sum them and see if that sum equals. And yes, it does. So, we have proven that we have created the right triangle with optimal shape. You may be surprised that the optimal triangular shape is not an equilateral triangle. Since the equilateral triangle in this instance would have each side equal to 12.5 meters, we can solve for its height h prime as follows. Thus, the area A 12.5 of the equilateral triangle can be written. We clearly see that our derived design is better than the equilateral design. Looking at the ratio of the two areas, we find, thus, we learn that moving from an equilateral triangle design to an optimal one increases area by more than 15%.
By the way, Halim and all students, do you notice that the maximum areas we get from the best rectangle and from the best triangle are identical, which is 781 over 8 meters squared?
Oh yes, true. Isn't this interesting? After this lesson, you may want to investigate other geometrical shapes to see if you can find any shape which is better than the optimally designed rectangle and triangle that we have discovered today.
For instance, what about a pen that has a semicircular shape? You may discuss it with your teacher in the next class.
In conclusion, in order to determine the maximum area or volume for certain shapes, we can find the maximum area from the quadratic function or cubic graph, or we can differentiate the quadratic equation or cubic equation to find the value of unknown and substitute into the formula area of quadratic equation or cubic equation. Let's go back to the question which I posed at the beginning of the lesson. Why do you think that Mr. Hadi and Amin would like to maximize the area of the pen? Well, the answer is, with a fixed amount of fencing, the sheep can have maximum amount of grass to eat. They will grow big and strong.
Hope all of you have had great time with us.
Till we meet again.
Bye.
Bye. At the end of the lesson, a student should be able to, first, apply the concept of differentiation to find the maximum area. Second, apply the concept of differentiation in daily life activities. But bear in mind, before watching this video, a student should have prior knowledge on, first, how to differentiate a function, second, how to draw graph, and third, how to find area and volume of various shapes. I would like to suggest some activities. For instance, teacher can use any shape of pen in doing the activity. And as for activity 2 and 3, you may want to encourage your students to use open source software such as Spreadsheet. You can download the software from this link. You may want to also provide a handout for your students so that they will have clear instructions and guidance on using the software. Please refer to this link or download the handout. For your reference, this is the answer to the homework related to semicircular shape. Please refer to given handout.